In this unit, we've been reviewing the prerequisite skills that you need to be successful in AP Calculus. Now let's review exponential and logarithmic equations. Let's get started. Now, natural log x and e to the x power are inverse functions. So there's a cool property that is very useful. If you raise base e to a natural log power, they cancel each other out. So an easy way to solve this problem would be to give both sides of the equation a base e. On the left side, these cancel each other out and leave you with x plus 3 is equal to e squared. Now we just subtract 3 from both sides and you get x equals e squared minus 3. And that's it. So easy. For problem B, we will end up using the product rule. So remember that if you have the log of A plus the log of B, you can write that as the single log of A times B. So in this case, that will give us the log of 4x. And this will equal 1. Now let's use the little trick I showed you on the previous problem and give each side of the equation a base e. These will now cancel each other out and leave you with 4x. And then, of course, e to the 1 power is just e. Dividing both sides by 4, we get x is equal to e over 4. How easy is that? I've recopied the problem so I can really show you what I am doing. Remember that natural log and base e are inverses. So I can cancel this out by doing the natural log of both sides of the equation. Natural log and base e cancel each other out, so we are left with 4x plus 5 is equal to the natural log of 1. We know the value of this. I feel like I should do a little side lesson over here. Let's remember how logs work. If I say the log base 2 of 8, this is asking the question 2 to the what power is equal to 8. So the value of this expression would be 3 because 2 to the third power is 8. So this log of 1, let me just rewrite this real quick. So log of 1, natural log of 1 is the same thing as log base e of 1. So this is asking the question, e to the what power is equal to 1? Well, we learned a while back that if you take anything and raise it to the 0 power, that's going to give you 1. So that's why the natural log of 1 is 0. Because again, this is base e, and we're saying e to the what power is 1? The 0 power. So that's the answer. And then the rest is just a basic algebra. Subtracting 5 from both sides and dividing by 4, you get x is equal to negative 5 fourths. Okay, so there are many ways to solve this problem, but I think that the simplest way is to recognize that both of these can be written with the same base, base 2. So the left side, we already have a base 2, so I'm just going to leave it like it is, 2 to the x power. But this 8 could be written as 2 to the third power. So I'm going to rewrite it that way so they have the same base. But you see we have this exponent of 4x minus 1 up here. Just go ahead and put that in parentheses. Okay, so these are now being multiplied. If you have two expressions that have the same base and you set them equal to each other, that will only happen if the exponents are also equal. So logically, we know that x must equal 3 times 4x minus 1. All right, if the bases are equal, the exponents must be equal. So we've just made this logical leap. Of course, we can do the distributive property here, so we get x is equal to 12x minus 3. Let's see, I guess I will add 3 to both sides. So that will give me x plus 3 is equal to 12x. And then now I will subtract x from both sides, and that will give me 3 is equal to 11x. Dividing both sides by 11 gives me x is equal to 3 over 11. Okay, it's time to use the power rule of logarithms. Remember that for logarithms, if you have a number in the front, so if I have 3 natural log x, the power rule says I can take that 3 and make it the exponent. So this would be the same as natural log of x to the third power. But that's exactly what we have if you just focus on the exponent only. Ignore everything else for a second. The 3 in the front is going to become the exponent because of the power rule. So leaving everything else the same, I have e to the natural log of x to the third power. But as we have discussed a couple of times now, e to the x power and natural log x are inverses. So these cancel each other out. And that leaves you with just x to the third power. So now we have x to the third power equals 64. And fairly basic algebra, we will just take the cube root of both sides. And the cube root of 64 is 4. So we have x is equal to 4. All right, time for the product rule again. So when you have the sum of 2 logs, you can write it as a single log of the product of these 2 arguments. So we will have the natural log of x times x plus 2. All right, now we have the natural log of something equals the natural log of something. This is only going to be valid if the 2 arguments are the same. The stuff inside of a function is called the argument. So logically, we know that x times x plus 2 must equal 3. Be careful, this process can yield some extraneous solutions. So whatever we get, we need to just look back and make sure that they are valid solutions. Anyway, if I distribute this, I get x squared plus 2x is equal to 3. This looks like we're going to have to do some factoring, so let's get 0 on one side. So we have x squared plus 2x minus 3 is equal to 0. Easily factorable. X squared will only factor as x times x. 3 will only factor as 1 times 3. We're shooting for a middle of positive 2. So I'm going to need a minus 1 and a positive 3. Also, negative 1 times 3 is negative 3, so that checks out. Using the zero product property, all right, I'm just in my head, I'm setting each of these equal to 0 and solving. So that will give me x is equal to 1 and x is equal to negative 3. But be careful. Look back at the original problem. You cannot take the log of a negative number. So if I were to substitute this negative 3 back in here, that would not be valid. All right, and think about it. The reason why you can't take the log of a negative number, all right, let's say I try to do natural log of negative 3. Remember, this is asking the question, because we have a base e invisible here. This is asking the question, e to what power is going to give me -3? Well, e is a constant. It's 2.72 approximately. There's no way that you're going to take a positive number, raise it to some power, and have it be a negative number. That's not a thing. So this is an extraneous solution because you cannot take the log of a negative number. So just watch out for that. So x equals 1 is the only solution. Here's a fun little problem. Consider the function given by f of x equals a times e to the bx power, where a and b are constants. Let's do part A. Find the value of the constants a and b so that f at 0 equals 2 and f at 1 equals 10. Let's start with this fact. F at 0 equals 2. Let's see where this leads. F at 0 equals 2 means that if you plug in 0 for x, you're going to get 2 for the answer. So if I plug in 0 for x, we get a times e to the bx power. So that will become b times 0 power. And this is telling us if we plug in 0, we get 2 for the answer. So in this case, the answer should be 2. Well, b is a constant, so b times 0 is just 0. And anything to the 0 power is going to be 1. So I'm just going to wind up with a times 1, maybe I'll just show this one little step, is equal to 2, which of course means a is equal to 2. So we're halfway there. We found one of the constants already. Let's use the second fact. F at 1 is equal to 10. Let's see where that leads. So this means if we plug in 1 for x, we should get 10 for the answer. So looking at the function again, we have a times e to the b x power. But we're plugging in 1 for x, so this will be b times 1. And if we plug in 1 for x, we should get 10 for the answer. So all of this should equal 10. But guess what? We already know what a is. So we can go ahead and substitute that in. So we have 2 times e to the b power. B times 1 is just b. So I suppose we don't need these parentheses anymore. So we have 2 e to the b power is equal to 10. Dividing both sides by 2, we get e to the b power is equal to 5. I can get rid of this e by taking the natural log of both sides. Let me create a little space for myself so you can really see what I'm doing. I'm going to take the natural log of both sides of the equation. These are inverses, so natural log of base e, they cancel each other out. So that will leave me with b equals the natural log of 5, which is just a constant. So that's it. That's the exact answer. Part B is a fun little puzzle. We are to rewrite the function in the form f of x equals c times d to the x power, where c and d are constants. Well, remember, the original function is f of x equals a times e to the bx power. But in the previous part, we just found the value of a and b. So of course, let's start by substituting in the value of a and b. So there you go. But before I do the next step, I'm going to give you a little mini lesson off to the side. Let's say I had 7 to the third power, and then I wanted to raise that entire expression to the fourth power. How would I simplify this? Well, you know this would be 7 to the 12th power, because when you raise a power to a power, you multiply. Okay, great. Now imagine that instead of a 4, that was an x. So this would be 7 to the 3x power because still you multiply. Now, what if I gave it to you this way first? What if I gave you 7 to the 3x power? If for some reason I wanted to separate this out, I could rewrite this as 7 to the third power to the x power, because this would be the same thing. So that's what I'm going to do right now. I have this natural log 5 times x. So just focus on this part of it. But I'm going to rewrite this with e to the natural log 5. And then I'm going to take that x and put it outside of the parentheses. You can see these would be the same because when you have a power raised to another power, you multiply. And then now I'm going to bring that 2 back down. So I have f of x is equal to 2 times e to the natural log 5 all raised to the x power. But here we have that situation again where we have base e and then we have natural log. These will cancel each other out. So you end up with f of x equals 2 times 5 to the x power. And this is exactly what we were asked to find. A form of the equation where we had c times d to the x power. Here we have 2 times 5 to the x power. So that's the answer.